Hello everybody. I would like to start by asking you to try to remember the first time that you saw a drone. I know that I remember it quite vividly. There was this strange, unfamiliar buzzing noise, and I could see a small dot in the distance. It moved rapidly and it seemed to come closer. And as the dot became bigger, I saw a drone for the first time. Later that day I started googling, what would such a small toy cost? It was then that I realized that drones are not just toys anymore. The list with applications went on and on. Of course, filming, racing were always mentioned, but who would have thought about agriculture, bridge inspection, or border surveillance? And then finally there were these beautiful light shows. For my master thesis I worked with groups of drones, also called swarms. We are interested in swarms because they can do many more things than a single UAV. For instance, they can cover a large area, provide redundancy, and create new applications, such as providing network connectivity, carrying heavy loads, etc. I started with investigating the takeoff procedure. Existing solutions were slow and could not be used for large swarms. I quickly realized that this problem existed of two distinct parts. First, we must figure out which UAV goes to which place. And secondly, we must move the UAVs to that place as quickly as possible without any crashes. The first problem is called the assignment. The goal is to reduce the total distance traveled by all the drones, because this will save us time and battery life. Many solutions exist, which makes it time-consuming to search for the best one. Therefore, we created an heuristic. We also implemented the Königsegg algorithm. This existing algorithm, which was not yet used for any drone application, returns the assignment with the minimal total distance traveled by all the drones. After many experiments in our simulator ArduSim, the results shown that the heuristic calculated the assignment faster, and that drones only have to fly a bit longer. However, we also saw that the Königsegg algorithm reduces the number of flight paths crossing, and this last parameter is very important, because it reduces the chance of collisions. However, the Königsegg algorithm does not guarantee a collision-free flight, and therefore, currently the UAVs still have to take off in a sequential manner. But with the use of our results, we can start working on taking off the UAVs simultaneously. After that, I started working on maintaining the swarm that we just took off. In many applications, the drones have to fly from one waypoint to another. However, due to slight variations in flight speed, the formation can quickly fall apart. To solve this problem, we use a master-slave pattern, where each slave sends messages about their status. With the use of those messages, the formation is restored by the master at each waypoint. Of course, we also implemented a resilient mechanism in case of one of the UAVs would fail during the flight. Since in normal conditions the UAVs are sending messages, the absence of a message indicates that the UAV has failed. In that case, we took measures to remove the drone from the swarm and, if necessary, elect a new master. I hope that by now you are interested in my work. Feel free to read the works that we have published in this master thesis, or to ask me any questions.